Good morning, grade 11s. This video is on general solutions, specifically the more difficult types of examples. The last ones we did, I introduced you to the concept. So basically, like for example, if you had sine x equals 0, 2, 1. Your first step would be to find your reference angle. So you would shift sine of that to get what x equaled. Then you would check whether sine was positive or negative, which quadrant that was, and then you would come up with two solutions. So for example, this is positive, so I would have a solution for quadrant 1 and quadrant 2. Okay, so now we're going to move on to 4 types of general solutions that are a little bit more difficult. There's actually another type as well, but I don't see any in the past papers. So if I come across one, I'll do it, but I'm going to focus on the common ones. Okay, so basically with type 1, you are looking out for a cos and a sine that are equal to or can be arranged so. So in other words, if you look at this one over here, I have one cos x and one sine x. There's no tan x, there's no sine squared, there's nothing. There's just one of each of these. And it can be arranged because if I take the sine x over, it becomes 3x equals sine x. Even if it was negative, it would be fine. If it was 3 cos x equals negative sine x, that's fine. Just as long as you can get one on each side of the equal sign. Okay, so this is what you're looking at for. One cos x, one sine x, and that they can be written equal to each other, or they already will be written that way. So let's go and write it that way. So we're going to have 3 cos x equals, if I take the sine x over, it becomes positive sine x. Okay, so now they are written the way that I want them to be. And basically with this type, you're going to divide by cos x. So let me show you why we'll do that. So let's see what happens here. I divide by cos x, and I divide this side by cos x. Okay, what's going to happen? So this side, the cos x's are going to disappear, and I'm just going to be left with 3. And that side, sine x over cos x is what? What is sine over cos? From your identities, we know that is tan x. Okay, so this very much just looks like the first stuff we did. So if I just write it neatly. So tan x equals 3. So now you can just follow your general steps. So x is shift tan of 3. So x equals shift tan 3, which is 71, 57 degrees. Okay, and if you look at this, remember you're supposed to decide which quadrant. Where is tan clearly positive? In 1 and 3. So 1 is always simple. X is just equal to your reference angle plus minus k. And remember it's tan, so this is going to be k 180. So that's straightforward enough. Quadrant 3, remember quadrant 3 is 180 plus x. So quadrant 3, x is going to be 180 plus 71,57 plus minus k 180. So if you work it out, you just plus 180. You're going to get 251, 7 degrees plus minus k 180. Okay, so those are your 2 general solutions. I also saw that last week people were struggling with specific solutions. Specific solutions are very easy. They'll just give you an interval. So if they ask for all the specific solutions between minus 360 and 360, all you're going to do is you're going to do it for each of your formulas. So you replace k with 0, then 1, then 2, then 3. Remember, it just means 1 times 180, 2 times 180. And then there's a plus and a minus. So if you do 1, it's plus 1 times 180. And then you must immediately do 1 for minus. So minus 1 times 180. And you check your answers and you check whether they fall within this range that they've given you. And those are the answers that you will specify. Okay, alright, type 2. Type 2 may look a little similar to type 1, but that's what I want to show you the difference here. So with type 2, you're also looking for a sine and a cos that can be written as equal to, or they are equal to, but they have different angles. Okay, and this is highly important. So with type 1, it was both like cos x and sine x, so their angles are the same, they were both x. But with this one, this angle is 2x plus 30, that one is just x. Okay, so that's type 2, and you need to make sure that you do not go and divide by cos x because it's cos and sine. It's different. In this case, we're going to use co-ratios. So when you see the signs are different, or the angles are different, sorry, we're going to use co-ratios. So can you guys remember your co-ratio rule? Remember, sine x is the same as cos 90 minus x, and cos x is the same as sine 90 minus x. Those are the co-ratios that you learned. And it can even work for things like more things in the bracket. So let's say I have cos of 30 minus 2x, and I want to write this as sine. This can be sine of 90 minus this whole thing, minus 30 minus 2x. So that's why I'm writing it in a bracket, because it's minus the whole thing. So that would become sine 90 minus 30 is 60. And then minus 2x becomes plus 2x. So that's the same as that. But we started by using the co-ratios. So you can do that over here. I'm going to change sine to cos rather, because I just feel like the x is easier to work with. So I'll leave the cos over here. But sine x, I will make that cos, and instead of x, it'll be 90 minus x, because it is a co-ratio. Okay, so now you have cos angle equals cos angle, and they're both positive. So doesn't it make sense that if they're both the exact same, cos and cos, their angles must be equal if they are equal? So once you get into this point, this is the point that we want. This is the, in other words, it'll either be sine, sine, cos, cos, or whatever. Okay, so now you can go and you can drop the coses, and you can make the angles equal to each other. Okay, 2x plus 30 equals 90 minus x. Now, you may be tempted to go and solve for x. We will get there. But I want you to leave this whole thing as your reference angle. Do you remember before, I think we did an example where I explained to you that when you divide the x by something, you need to divide the K360 or the K180 by that thing as well. So I'm going to leave it like this, because once you put it into your two quadrants, there's something in front of this x, so when we divide, we need to divide that K180 or the K360 as well. Okay, so clearly cos is positive here, both positive, angles positive. Where is cos positive? Okay. So let's first decide which quadrants. It's in quadrant 1 and quadrant 4. Quadrant 4 is 360 minus. So for quadrant 1, it's simple. It's going to be 2x, so this whole thing, plus 30 is 90 minus x, plus minus k, 360. Remember, it's 360 because it's cos. So now we're going to take letters to the left and numbers to the right. So if I take the x over, 2x plus x becomes 3x. If I take the 30 over, 90 minus 30 becomes 60. Okay, and now you want to divide by 3. And do you see why I say don't do it up here? Do it here, because you need to divide the 360 by 3 as well. So 60 divided by 3 is just 20. 360 divided by 3 is just going to be 90. Okay, and that is your first general solution, quadrant 1. Now we must do quadrant 4. So, be careful, you're going to leave it exactly like this when you start. So 2x plus 30 equals. Now, the whole thing on this side is 90 minus x. So when you say 360 minus, remember this just represents your angle. When you say 360 minus, it's 360 minus, put this thing in a bracket. 90 minus x. You're minusing the whole thing. Okay, Then plus minus k, 360. So now we can go work it out. Becomes 360 minus 90, and minus x is plus x. Okay, so let's work out that. So 360 minus 90 is 270 plus x. Sorry, k 360. Then remember, you're going to take your x this side and your 30 that side. So 2x minus x is just x. Take the 30 over 270 minus 30 is just going to be 240. Okay, and that x is already alone, so there's nothing even to divide by. But you see why we needed to put this in a bracket, to ensure that when you minus it, the x became a positive. You're minusing this whole thing. Okay, so just to go through it one more time, you are looking for sine and cos, but with different angles. Okay, so once you see that there are different angles and they're equal to each other, you're going to use co-ratios. So you'll take one of them. You can change the cos to sine, or you can change the sine to cos. You say 90 minus. Once they are the same, you can drop the ratios and just make the angles equal to each other. So we just said 2x plus 30 equals 90 minus x. Once you got into that point, you follow your normal rules. You figure out which quadrant. So we knew it was 1 and 4. And remember to leave it in this form, because when you are dividing by something in front of the x, you are going to divide the 360 as well, or the 180 depending if it's 10 or whatever the story is. Okay, so that is type 2. Okay, we have 2 more types left, but I think I'll make a second video. I'm going to submit this video and then I'll make another video for type 3 and 4.